Good afternoon, all of you. So, in continuation of today's our morning lecture, we'll continue this topic, that is electrochemical grinding. Okay. Now we'll start this electrochemical grinding wheel material. Okay. So with this point, we'll start. So now bonding material. We should know the which are the materials can be used as a bonding in this grinding wheel. Okay, so what kind of bonding materials are used for this grinding wheel? That question will arise. So you can see in this on this slide. You can use copper, brass, nickel, or copper impregnated resin. Okay, so these are the bonding metals you can use. Also, you can use as metallic bonding metal in case of this electrochemical grinding operation. Okay, so now dressing. Okay, now the second point is that dressing. Okay, so now this dressing is also required because as a machining, as a 10% machining is there in that is due to the mechanical abrasion is there. Okay, so whatever this mechanical abrasion particles, whatever the tiny chips are actually generated, it may clog into the your grinding wheel. So then its performance will be reduced. Okay, so for doing that things, for dressing operation that is required, that reverse the current and do the electro grinding on a scrap piece of that workpiece, that is required. Okay, okay, so in normal case actually this grinding wheel, it is cathode and workpiece is anode, that is negative terminal, it is connected. But in case of during the dressing operation, what you have to do, you have to uh, change the your polarity of the, you have to change the polarity of your grinding wheel and your workpiece. So in that case your grinding wheel will be positively charged. Okay, and your workpiece will be negatively charged. Okay, so in that case what will happen, material will be removed from the your metallic grinding wheel. Okay, by anodic dissolution or resolution. Okay, so then that phrase abrasive particle will come outside. Okay, so a reverse current for dressing operation is required, and to do the yeah, that electrochemical grinding operation on a scrap piece of your workpiece. Okay, so in that case again that phrase abrasive particle will come outside, so it will deflate the metal bond by exposing the abrasive, that is called the dressing. Okay, we have to remove the that whatever the metallic grinding part is there, no? So that will be removed from your peel. That is called the dressing. Okay, so this is important. Again, another question is arises that which are the commonly used abrasives. Okay, in case of this, in case of this electrochemical machining. So commonly used abrasives here I have written that are aluminum oxide. Okay, its size 10 to 80 micron size is used. Okay, grid size. Okay, 10 to 80, sorry, 60 to 80 micron are used. Again, frequent wheel dressing is not required. Okay, like in normal grinding operation that we need sometime dressing. Okay, but here we not need any frequent wheel dressing. Okay, so because in process stirring of the metal bonding grinding wheel during the this electrochemical dressing, due to the dissolution of the grinding, that dissolution of your electrochemical. Okay, so that dressing will happen. So that is why it does not need any mechanical shear. Okay, so mechanical shear is unnecessary. And what water kind of electrode here you can use? Okay, electrolyte you can use as a water. But electrolyte should be electrically or chemical inert. Okay, to conduct the wheel bond material and your workpiece. Okay, so electrolyte should be chemically inert to conduct wheel bound material and your workpiece. Okay, that point also we need to take care. Then the another point is that what are the different or various process characteristics of this electrochemical grinding. Okay, so here the first process characteristic is that uh, material removal rate, again surface finish. Okay, that depends on the process parameters like wheel speed, at what rpm you are rotating that wheel. Okay, so what is the wheel fill speed or uh, workpiece speed rate. Okay, in case of a fixed grinding wheel. So again, electrolyte type, concentration of that electrolyte, delivery method, pressure, current, density, etc. So these are the different means, different process parameters are there on which your material removal rate and surface finish is different. Okay, again that current density, that is also important. Okay, because suppose higher current density, if we want to get that high material removal rate, then again high surface finish or better surface finish. So in that case we have to apply high speed rate. Okay, again high current density will increase your material removal rate. Okay, high current density will increase your material removal rate as well as your it will improve the surface finish also. Okay, it will improve surface finish. Okay, and again if you increase the that feed rate, okay, definitely you will get the high material removal rate, that is mrr, and surface finish will be improved. Okay, so high current density will increase the material removal rate as well as surface finish. Again it will improve surface finish also, it will increase the material removal rate. But if we increase the voltage, so in case of this, if we increase the voltage more than 4 to 15 volt, in that case due to the sparking, so it may leads to sparking at a wheel, at the front of your wheel. Okay, and it leads to the sparking, and it deteriorates the surface of that of this surface finish, and it may damage your grinding wheel also. Okay, so that point also we need to take care. Okay, then again another process characteristic is that in case of this electrochemical grinding, the material removal rate can be as high as 10, that material removal rate can be as high as 10 times of your greater than your conventional grinding. Okay, on your hard material. Okay, you will get that more than hard material having more than 65 HRC. Okay, so it you will get the that material removal rate greater, the greater than your conventional. Okay, again that 10 times more than your conventional machining of okay of or for hard material of having 65 HRC workpiece. Okay, so it is a bulk process. Okay, this is electrochemical grinding, it is a bulk process, it is a cold process. So here this temperature does not go beyond the your 100 degrees centigrade, because whatever this temperature is generated now, because this electrolyte is forced to flow in between your grinding wheel and your workpiece. Okay, so that your temperature actually it is automatically controlled. Okay, so whatever the heat is generated, it is taken outside during that process. So temperature is automatically controlled. Again go due to that it does not go beyond the 100 degrees centigrade. So if goes beyond that, then there is a structure damage and the grinding cracks may generate. So due to that maybe poor fatigue strength is observed in case of the electrochemical grinded workpiece, because there is a stray cutting may occur. Okay, by this grinding wheel. So because of stray cutting are there, no? Then small pits are actually generated on your machined surface. So due to that stray cutting, uh, that current attack leaves the series of pits on your workpiece surface. So it acts as a sites for the your fatigue crack intimation. Okay. Now another point, that machining condition. Okay, if we give feed rate in that case than the your required one, no? Okay, so that means if you give the feed rate higher than the required, then prematurely a detached abrasive particle will be there, and it may leads to the excessive grinding will be there. Okay, and again, if you provide or if you give the lower feed rate than required, then it will leads to your larger overcut, that means the poor tolerance, and you it may give the poor surface finish. Okay, so if we increase the feed, then also we have the problem. Then if you if you provide low feed rate, that time also you will not get the uh, proper surface finish. So we have to give the optimal feed rate. Okay, then another that inter-electrode gap. So internal gap generally 0.25 mm for freshly dressed wheel it is provided. Abrasive particle maintain the electrical insulation between your cathode and the anode, and it determines the effective gap between them, as well as that 0.25 gap. Okay, okay, so determine effective gap between the them. Okay, as well as point not 25 mm, and wheel surface speed you have to maintain 1200 to 1800 meter per minute, and depth of cut we have to maintain below 2.5 mm, and it should be limited by wheel contact arc length. It should not exceed 19 mm. It should not exceed 19 mm. Then electrolyte become effective due to the higher concentration of that hydrogen gas bubbles, and due to again the sludge formation in between the electro gap. Due to that only we have to go for the recirculation of the electrolyte. Okay, and before recirculation we have to filter that. That point also is important. Then there are various process perform there are the process performance. Okay, so best tolerance obtained by this process is plus minus 25 micron is there. Then a minimum outside corner radius is point not 25 is there, but inner radius minimum uh, that inner radius corner radius is minimum, that is 0.25 mm. Again, a surface roughness that can be obtained using this electrochemical grinding process is 0.12 to 0.8 micron. Then workpiece surface, as there is no burr, so there is no scratches are there. And as we know that burrs and what are the scratches are there, okay, that get dissolved in zone number 3 by electrochemical dissolution process. Okay, so due to that only your workpiece surface will be the free of your burrs and the scratches. Again, there is a very reduced risk of thermal damage, because temperature does not go beyond 100 degrees centigrade, and whatever the heat is generated is carried away by the electrolyte. So due to that there is a uh, low risk of thermal damage. Again, a cost of machining in case of this electrochemical grinding is it is very less, because here in this electrochemical grinding material removal rate is very high than your normal grinding operation. So that is why cost of your machining is very high in case of this uh, cost of machining in case of electrochemical grinding uh, is a very high in case of this electrochemical grinding operation. Cost of machining is very actually it is less. Okay, in case of electrochemical grinding. Okay, because as we know that cost of machining by conventional grinding operation is more, and cost of machining in case of this electrochemical grinding operation is less. But electrochemical grinding here machine tools are actually costlier than your grinding uh, operation conventional. Okay, This point you should remember. So these are the process. So these are the process performance. That means up to what tolerance we have to obtain, then what minimum inside corner radius we can achieve, then surface roughness up to what you can achieve, whether heat applicator zones will be produced or not, then whether your workpiece surface is burr free or scratches may occur. So these points means your process. Now we'll go for the last part, that is application. Okay, so here I have shown some applications. So there are various applications are there for this electrochemical grinding operation. So first application is that this process, electrochemical grinding process, it is used for grinding of carbide cutting tools. Okay. uh, Again, so it is economical in grinding carbide cutting tool. Okay, again this electrochemical grinding, that electrochemical grinding cemented carbide workpiece. So no damage to your microstructure, no micro cracks will be occur, or no any other defects are there. If you go for the electrochemical grinding of your ground cemented carbide workpiece, then you will not get, you will not, that will not change any microstructure or micro cracks. Okay, so we will not get any defect. Okay, so it is safe for the grinding of carbide cutting tool or the cemented carbide also. Again, for a reprofiling worn locomotive traction gear, so wear marks removed from the gear to surface by removing a point 38 thick layer of the material from your gear, and there is it does not again uh, does not get that change the gear hardness. Actually, it does not detect that it does not reduce that gear hardness. That means there is no effect on your gear hardness. Okay, so you can go for the reprofiling of that worn locomotive traction motor gears. Okay, again, uh, this process it is also used for burr free sharpening of the uh, hypodermic needle. Okay, for that purpose so we can use this electrochemical grinding. So again, grinding of the superalloys turbine blades, again, form grinding of the fragile aerospace honeycomb materials. So that can actually it is done by this electrochemical grinding operation. Okay, so these are the applications. So I request all of you, please write down these applications. Write down the applications. All of you, please write down these applications, because you should know the what is the difference between your conventional grinding and what are the plus points about this electrochemical grinding. Actually, this is a uh, hybrid machining process, because here we have combined electrochemical machining and your conventional grinding. Okay, we have another one hybrid machining process, that is electro stream drilling is there. Okay, because it is not in our syllabus. For your information, again, that shaped tool tube electrolytic machining is there. Okay, so these are the applications. I will give 2 minutes to write this. Again, I think you should write. Uh, one minute, After this, you can write down another. I will show. Okay. Now write down this process characteristics. Process characteristics. Okay, so with this we have completed our chapter number unit number 4. Okay, now I will show some good YouTube that some short videos related to this grinding. Okay,
Today we will discuss about ECG, electrochemical grinding machining and mechanism of its material
I
removal.
think voice
So
is audible.
ECG, which utilizes a
Your
workpiece,
voice is audible
positive
at your end,
workpiece,
all of
this
you.
is positive charged,
Say yes or no in the chat
and
box.
negative charged grinding wheel. This is the negative charge and this is the power, here power is DC power supply, and here
In this
current
video,
rating
you
that
will get
varies
the
from
what is the
50 to
mechanism of material
300
movement.
ampere. Today we about ECG, electrochemical grinding machining and mechanism of its material removal. So ECG, which utilizes a workpiece,
Please
positive
listen
workpiece,
carefully.
this is positive charged, and negative charged grinding wheel. This is the negative charge and this is the power, here power is DC power supply, and here current rating that varies from 50 to 300 ampere, and grinding wheel that is with metallic bond. Aluminium and diamond are used as insulating material of grinding wheel to set in conductive material, and electrolyte is used in between grinding wheel and workpiece, and a space is maintained between workpiece and grinding wheel that is approximate 0.025 mm. So electrolyte is used, and this space is generally maintained to flush the electrolyte between workpiece and grinding wheel. So when feed is provided to the workpiece in along right hand side to the workpiece, then grinding wheel starts to rotate continuously with a surface speed of 20 to 35 meter per second, and the non-conductive particle act as spacer between anodic workpiece and wheel. So this is the non-conductive particles which act as spacer. So hence this abrasive continuously removes the machining product from the workpiece area. Continuously, grinding wheel is rotating, feed is provided to the workpiece, and electrolyte is continuously supplied between the space. So that's why here is the removal of the machining product from the workpiece. And now I want to discuss some applications of ECG. ECG generally it is used for the production of tungsten carbide and fragile parts and also thin wall tubes. And this is also used for producing the specimen for fatigue and tensile test. Here are some advantages of ECG, as it provides the good surface quality and it also eliminate the grinding burr. But with all these application and advantages, it has some disadvantage. Initial cost of electrochemical grinding machining is highest, much higher than conventional machining, and this process is limited to the electrically conductive material only. Subscribe to get more updates and Universe Double Two. You may like, share and comment and give your suggestions if required. Thank you. Have a nice day.
Today we will discuss about electrochemical grinding process. It is the combination of ECM and grinding process, electrochemical machining and grinding process. It removes material from electrically conducting workpiece with the help of abrasive wheel bonded with insulating grit in conductive bond material. Firstly, we will discuss about parts of the electrochemical grinding. We have a fixture on which our workpiece will be placed. Workpiece is connected to the positive charge from the power supply. There is a electrolyte pump and nozzle connected with the help of pipe and filter. Pressure gauge and flow meter are also attached to the pipe for maintaining the flow of the electrolyte. There is a container which will collect the electrolyte coming from the workpiece. There is a abrasive wheel which is used for removing material from the workpiece. These are the sleeve and attached to the negative charge of the power supply. This insulating grit can be of diamond dust or silicon carbide or boron nitride according to the use. This is sleeve for providing negative charge to the shaft of the abrasive wheel. Now we see the process of electrochemical grinding. DC power source will supply the power to the tool and the workpiece. Here pump will start rotating and it will suck the electrolyte from the electrolyte container, and this electrolyte will reach to the nozzle, and this nozzle will spray this electrolyte in between the abrasive wheel and workpiece, and oxide layers were removed by the insulating grit of the abrasive wheel. So this is the working of the electrochemical grinding process. Thank you for seeing this video. For more updated videos, you can subscribe me on my channel, Learn and Grow. Thank you.
Today we will discuss electrochemical grinding. This combines the traditional electrochemical machining and grinding and aluminium oxide. And so during the process, electrolyte fluid, typically sodium nitrate.
Today we will discuss about electrochemical grinding process. It is the combination of ECM and grinding process.
Today we will discuss about ECG, electrochemical grinding wheel and the workpiece. This is the abrasive that is coming out from the nozzle, and this is the path of the abrasive from the tank.
Electrochemical machining process. Electrochemical machining, or ECM, is a method of removing metal by an electrochemical process. It is normally used for mass production and is used for machining extremely hard materials or materials that are difficult to machine using conventional methods. Its use is limited to electrically conductive materials. This video will cover the following about electrochemical machining process. 1. Working principle. 2. Construction. 3. Working. 4. Applications. 5. Advantages and disadvantages. Working principle. Whenever the two electrodes, anode which is connected to positive terminal and cathode which is connected to negative terminal, is immersed in an electrolyte, such as NaCl. When the voltage is applied across the two electrodes, the material removal from the anode starts. The anode and cathode is placed very close to each other without touching. In ECM, the material removal takes place at atomic level, so it produces a mirror finish surface. ECM working is opposite to the electrochemical or galvanic coating or deposition process. Let us understand the chemical reaction taking place in this process. As the potential difference is applied across the electrode, the movement of ions starts in between the tool and workpiece. The positive ions moves towards the tool and negative ions move towards the workpiece. At cathode, the hydrogen ions takes electrons and gets converted into hydrogen gas. In the same way the iron atoms comes out from the anode, which is workpiece, as Fe++ ions. Within the electrolyte, the sodium ions combines with hydroxyl ions and form sodium hydroxide, and ferrous ion combine with chloride ions and forms ferrous chloride. Also iron ions combine with hydroxyl ions and form iron hydroxide. In the electrolyte, the FeCl2 and FeO2 produced and gets precipitated in the form of sludge and settle down. In this way, the material is removed from the workpiece as sludge. The various reactions taking place in the electrochemical machining process are as follows. Construction. Electrochemical machining setup consists of following parts. Power supply. It requires a DC power supply for machining purpose. Electrolyte. The electrolyte has three main roles in the ECM process. It carries the current between the tool and the workpiece. It removes the products of the reaction from the internal electrode gap, and it removes the heat produced from the passage of the current. Tool. Tool is a replica of the shape required on the workpiece. Tank. This holds the electrolyte in which the tool and workpiece are immersed. Workpiece. Workpiece holding table. Pressure gauge. It shows the pressure at which the electrolyte is supplied to the tool. Flow meter. It shows the rate of flow of electrolyte to the machining area. Flow control valve. This helps in controlling the rate of flow of electrolyte. Pressure relief valve. In case the pressure in the supply lines increase, this pressure relief valve opens and bypasses the electrolyte to the tank. Pump. Pump helps in circulating the electrolyte. Reservoir tank. Stores the electrolyte. Filter. It helps in filtering the impurities present in the electrolyte which may chock the supply lines. Centrifuge. It helps in separating the slug from the electrolyte. Slug container. Stores the slug produced during the machining process. Working of electrochemical machining. First, the workpiece is assembled in the fixture and the tool is brought close to the workpiece. The tool and workpiece is immersed in a suitable electrolyte. After that, a potential difference is applied across the workpiece, which is anode, and tool, which is cathode. The removal of material starts. The material is removed in the same manner as we have discussed in the working principle. Tool feed system advances the tool towards the workpiece and always keeps a required gap in between them. The material from the workpiece comes out as positive ions and combine with the ions present in the electrolyte and precipitates as sludge. Hydrogen gas is liberated at the cathode during the machining process. Since the dissociation of the material from the workpiece takes place at atomic level, so it gives excellent surface finish. The sludge from the tank is taken out and separated from the electrolyte. The electrolyte after filtration again transported to the tank for the machining process. Application. The ECM process is used for die sinking operation, profiling and contouring, drilling, grinding, trepanning and micro-machining. It is used for machining steam turbine blades within closed limits. Advantages. Negligible tool wear. Complex and concave curvature parts can be produced easily by the use of convex and concave tools. No forces and residual stress are produced because there is no direct contact between tool and workpiece. An excellent surface finish is produced. Less heat is generated. Disadvantages. The risk of corrosion for tool, workpiece, and equipment increases in the case of saline and acidic electrolyte. Electrochemical machining is capable of machining electrically conductive materials only. High power consumption. High initial investment cost. If you are new to ADTW, subscribe our channel to get all latest updates from us. And click on the like button if found this video useful. Also, if want more videos.
Hey, I'm Kevin from Vsauce 2, and Darwin's bark spider, found only in Madagascar, spins the toughest biological material known to man. But after about a day, tiny specks of dust in nature, the burring eliminates reasonably perfect result. The charge is connected to the part, making it the anode, and the negative charge across the surface. In this case, for doing the electrolytic flow down, which makes the electrical connection with the part, activate the spider ECD with the foot switch, and notice the flowing electrolyte. Using the voltage adjust knob, the voltage is regulated up until about 10 amps of current flow, and you see the fluid is bubbling, indicating the deburring work is in process, and after a predetermined set time, it automatically shuts the ECD process off. Upon completion, you can see the newly created radius on the edge of the gear teeth. Using interchangeable handheld probes in the lower-powered Spider ECD Model 1001 machine, we can easily deburr holes and cross-hole intersections. This one features 4.
Hi guys, welcome back to MMI. So guys, in this video we are going to learn the another non-traditional machining process, that is electrochemical machining. In this video we are going to learn the principle of electrochemical machining, the total working of electrochemical machining, what kind of equipments which is used in this process. Also we'll check out the applications of ECM and its advantages and disadvantages of this ECM process, which is known as electrochemical machining process of ECM. So guys, before beginning to our chapter, I just request you to please subscribe to my channel AMI, that is the engineering and technology related channel. We do post videos regularly also. Also guys, after subscribing, please hit the bell icon so you will get a notification, instant notification of my videos. So let's begin with our topic, that is ECM. So guys, the ECM is known as the electrochemical machining process, which is a super finishing process, or we can call it as it is a non-conventional machining process, non-traditional machining process. So basically guys, this process is widely used because of this industrial advantages, and it is adopted by many of the industries. Also guys, this process is inverse of the electroplating. So guys, let's begin with the principle of the electrochemical machining process. So guys, the ECM works on the basic principle of the Faraday's law of electrolysis. So guys, as we can see over here in this image, these two cathode and the anode electrodes are placed in the electrolytes. That is, the two electrodes are placed inside the container which is filled with the solution which is known as the electrolyte, that can be of NaCl plus water, that is electrolyte. Okay. So guys, when we connected this cathode and anode, the battery or voltage is applied between them. This anode, the ions which is move from anode to cathode, that is the electrons moves from anode to cathode, that is anode which is known as the positive terminal, and this the flow of the electron, or we can call as the flow of the metal, is goes to the cathode, that is the negative terminal of the battery. So guys, that was the basic principle of this Faraday's law of electrolysis. Let's check out the suppose I have a battery over here. So the battery, to the negative terminal of the battery, the tool is connected, which is works at the cathode, and guys, the to the positive terminal of the battery, the workpiece is connected, which works as a anode because it's connected to the positive terminal. So guys, this whole tool and the workpiece is placed inside the container which is filled with the electrolyte solution. And guys, that between the tool and the workpiece, the gap is very less, because in this ECM process the gap needs to be very less. So guys, when we switch on the current supply and we apply the potential difference across the battery or the solution, the metal removal takes place from workpiece to the tool. So guys, that was the fundamental of the electrochemical machining, or we can also call it as the basic principle of the electrochemical machining. So let's check out what kind of the equipments which is used in ECM process. So guys, as we can see over here in this case, the tool and the workpiece is there, which is supplied by the power supply. The first one is the power supply in the equipments. So guys, in the ECM, the high value of the direct current, that is are around 40,000 amperes are applied, and the low value of potential different is desirable. So over here, high value of the current and low value of the potential difference. So guys, the as you can see, this electrode, the gap is very less between the workpiece and the electrode, and the electrode is placed inside the inter electro gap, so which is very desirable for the machining. Inter electro gap, that this is very important guys over here in this case. So there is this continuous supply of the cleaning system is there. This one is the next, that is followed by the piping system, storage tank, pumps, control valves, pressure gauges, heating and the cooling coils, that is the electrolyte supply, that is the continuous electrolyte supply over there. Over there, next one is the in the equipment, that is the tool and the feed system. So guys, the tool is made by the anti-corrosive material, so because it has to withstand in the corrosive environment, that is of the electrolyte and everything. So high thermal conductivity in the tool has needs to be there for the easy machinability. The next one in the equipment is our workpiece and the work holding device, that is the workpiece and the work holding device, work holding system we can call it as. So the workpiece should be well electric conductive, and the workpiece takes as so guys, in this process the workpiece works as an anode. In this process, the work holding device should have the non-conductive electrical properties. So guys, next we'll see the working process of the ECM. So guys, as we all know, the ECM is the inverse of the electroplating process. The metal is removed from anode into electrolyte. In the ECM, the electrolyte is so chosen that there is no plating on the tool, and the shape of the tool remains unchanged. The shape needs to be constant in this case. Generally, the NaCl into water takes as an electrolyte, that is our brine. The tool is connected to the negative terminal and works as a work is connected to the positive terminal. So guys, when the current is passes through the electrolyte, or the reaction occurs at anode or the workpiece, and at the cathode or tool, that is reaction occurs at the both the ends. So to understand the proper working, let's take an example of the machining low carbon steel. So guys, when we apply the potential difference between the low carbon steel, that is the ionic dissolution takes place in the electrolyte, as the electrolyte contains of the NaCl and water, that is H2O. The ionic the reactions are as follows: the NaCl split into Na plus Cl minus, and H2O splits into H plus and OH minus. That is the ionic dissolution in the electrolyte. So guys, when we applied the potential difference between the tool and the workpiece, so the positive ions goes to the tool, that is from anode to cathode, and negative ions goes to the workpiece. That was on the basis of the Faraday's law of electrolysis. So we can see over here in this image as well this movement of the ions, that is from positive to negative. So the hydrogen ion moves towards the tools, and the hydrogen reaches the tool. It takes some electrons from it to convert into gas, and this gas goes into environment. Okay, and when the hydrogen ion takes electrons from the tool, it creates the lack of electron in the mixture, or we can call it as in the electrolyte. To compensate that lack of electrons, the ferrous ion created at the workpiece, that is anode, which gives the equal amount of electron in the mixture. So guys, over here these reactions which occurred at the anode, and the anode, that is the 2H plus 2 electron gives us H2 at cathode, means those are at anode and cathode respectively. So guys, this ferrous ion reacts with the opposite chlorine ions in hydroxyl ions and get precipitate in the form of sludge. So guys, these are the reaction which forms the sludge, and for that removal of the sludge we need that particular system. which contains the pumps and pressure gauges respectively. So this will give the ferrous or iron into electrolyte to complete the machining process. So guys, this machining process gives the high surface finish, and because of the machining is done atom by atom. So guys, the next one will see the applications of the ECM process. So guys, there is a wide ranges of the application. The ECM is used to machining the disc or turbine rotor blade. Machining the disc or turbine rotor blade. It can be used for slotting very thin wall collets. That is for the precise machining, we can call it as. ECM can be used to generate the internal profile of the internal cam, the products of the satellite rings and connecting rod, and machining of the gears and the longer profile, etc. Where it is high accuracy and high precision is required, we can go for this ECM process. Next is the advantages and disadvantages of ECM process. It can be machined very complicated shapes and surfaces. We can do machining very easily. No tool wear occurs over here. In this case occurs because there is no direct contact of the tool and workpiece. The machining of the metal is independent on strength and hardness of the tool. The ECM gives very high surface finish, and over here that was the advantages. In case of disadvantage, high initial cost of the machine. The design and the tooling system is complicated, and it is very complex over here. The non-conductive material cannot be machined over here. In this case, that is a disadvantage mainly. The blind hole cannot be machined from ECM. The space and the floor area which is required is more in this case of high over here. So guys, we have seen over here, we have learned all about the ECM electrochemical process. We have seen the principle, we have seen the equipments, we have seen the actual process, applications, advantages and disadvantages. So guys, I hope you like my video. If you like my video, please hit like. If you have any doubts and comments, please do comment below.
Okay, so this was about the electrochemical machining and grinding. Okay, so in next lecture we'll start our new unit number 5. Okay, so already I have taken the attendance from chat box. Okay, don't worry. So thank you very much. You can leave this meeting now. Thank you.